In this tutorial, you will learn how to test the pickup value and the trip time of the reverse power generator protection function. Conventional testing of generator protection functions is a big challenge. Without having a proper PQ plane to work with, it needs a lot of imagination and calculations to test all power protection functions. Additionally, you need a lot of different test modules to set up your test. Typical generator protection relay characteristics for reverse power protection are defined as boundaries in the PQ plane. For a convenient way of testing and assessing the relay settings, a graphical illustration of the characteristic, as well as a visual definition of the test shots and ramps in the PQ plane, would be very helpful. Those needs are met by the test modules Power and Advanced Power, which make testing power protection functions much easier and visual. In this tutorial, we will use the Advanced Power module. In our example, we test the reverse power generator protection function. The nominal power is 173 watt and the pickup value is 3% of the nominal value, which is 5.2 watt. The angle phi of the power characteristic is set to 0 degree and the trip time is 1 second. We have already prepared an OCC document with a test object and a hardware configuration. For testing the reverse power function, we create a new group in the OCC file and insert an Advanced Power module. The Advanced Power module offers two options for testing in the power plane: the shot test and the ramp test. We will begin by configuring the test object with special attention to the RIO block for power protection. This RIO block Power comprises two tabs, one for general settings and the other one for defining the zones in the PQ plane. Let's start with the System Settings tab. In the upper part, we define the CT star point connection and the reference for relative power. Make sure to set the CT star point connection as it is in the relay, because it is essential for the power direction. The tolerances for power and time are required for the test assessments. They vary depending on the relay and are specified in the manual. The absolute and relative tolerances can each be defined, but the larger of the values is dynamically applied. If the relay manual does not state an angle tolerance, you may start off using the default setting in the test object. Some power protection functions are only active for a certain voltage or current range. In this case, a voltage and a current threshold can be set to allow for an automated assessment by the test module. In the Zone Settings tab, the zone characteristics can be defined. The Zones table contains a listing of all defined zones for all known zone types. We add a new trip zone to define the reverse power area. To simplify entering the settings, some common characteristic shapes are available as predefined types. We choose the percentage shape type. As zone orientation, we select -P. In this case, the blinder is 0 degree and the minimum value of P is 3%. To finish defining the characteristic, we enter the nominal trip time of the zone, adding the minimum operating time of the relay under test. Besides tripping zones, you can also define zones of the type Show Only, Do Not Test, and Alarm. For example, you can use a Show Only zone to display the generator capability curve during the test. Such a curve can be drawn using lines and segments. In the next step, we will configure the hardware. For the test, we require 3 voltages and 3 currents. We assign a trip contact of the relay to binary input 1, as trip zones expect a binary input assigned to trip. In addition, we assign the start contact to detect when the relay picks up. If you had also defined an alarm zone, it would expect a trigger signal at the binary input assigned to alarm. We do not require any binary outputs for the test. Now we can set up the tests.